And welcome, this is Edexcel S1, June 2011. This is question 1, okay? So we're given this, the information that I've listed on the board, okay? So we've got that the SXX, okay, is 3,535,237.5. That the sum of Y, this A just means the sum of, okay, the sum of Y is 181. The sum of Y squared is 4,305. SXY is negative 23,726.25. Now, obviously, you should still tell straight away that we've obviously not got SYY. And in the first question, we're asked to work that out. Okay. Now, what I've done is I've put the formula on the board for SYY, which is EY, the sum of Y squared, take the sum of Y all squared, okay, over the number of whatever we're looking at, okay? So basically, we're looking at the, all you read is the first paragraph, and we're told that there's 8 North European towns, okay? So obviously, therefore, you could also put in here, n is equal to 8. Alright, now we're just subbing the individual terms and put it in our calculator, okay? So it's fairly simple. So the sum of Y squared, 4,305. If you're unsure, it's obviously always the bigger number that you're taking away from. Just makes sense, okay? Because, well, it's not always, but it's, you know, whatever. Okay, so it's 4,305. Take 181, but remember 181 is squared. Okay, so I'm just going to leave that in brackets over 8. Okay, so you could work that out what 181 squared over 8 is, and then take that away from 4,305, and you get SYY to be 209.9 to 3 significant figures. Okay, put it to 3 significant figures, because the next question, part B, also asks us to do that. So it's going to be a common theme of accuracy. But as I said, it doesn't really matter what you put it to. Okay, it's just a reasonable degree. So, as I said, it's up to you, really. Now, the next part asks us to calculate the 3 significant figures, the product, moment, correlation, coefficient. Now, this is given in your formula sheet, but you should know it off by heart anyway, really. R is equal to SXY over the square root of SXX times SYY. And we've got all the individual terms now because we've just worked out SYY. Obviously you're going to tell it's going to be negative because our number on top is going to be negative. Okay, so it's R, I just call it, you could put PMCC, I just wrote R because, well, I'm weird and I'm doing the video. So it's negative 23,726.25 over the square root of SXX, which is this 3,537.5, and we're times that by SYY. Now, as I said, that I've rounded this answer of SYY, so you could put straight 181 squared over 8 here, but obviously I'm just going to put 209.9. But for accuracy, I'll just sub in the last answer you got for part A, okay? When you work out R, you should get R to be a value of negative 8.71, 0.871, okay? And that's the 3 significant figures because that's the accuracy is asked for in the question. So obviously you get an accuracy mark as well. So you'll see that's worth 2 marks. You get 1 mark for the actual formula and the other for the obviously answer to the correct degree of accuracy. There's no point giving an answer to 4 significant figures because obviously you do the opposite of what you're told, and really, that's for the rebellious kids at heart, and maths isn't for them. Okay, so anyway, the next part C, just asked us to give an interpretation of your coefficient. Okay, now, as I said, it's just a case of, well, what it's saying, what does this actually mean? Okay, so you have to, I know it's only worth 1 mark, but really there's 2 things that you need to say to get this 1 mark. Then we're going to write them down, obviously, because I could just talk you through it. Now, obviously the first thing you need to state is the fact that it's a negative. And what does that mean? Well, obviously shows there's a negative correlation, but not just any negative correlation. Because this is quite close to 1 in terms of, remember the PMCC just represents, so we've got, when we look at the scatter diagram, okay, scatter plot, it's how close is the line of best fit of the points close to 1, okay, so if it had a gradient of 1, it'd be sort of proportional, okay. So what it's saying is how linear is this graph, and what it's saying there is it's quite linear, Okay, so it's really strong, but obviously it's not 1, but it's almost 0.9, which is obviously very strong. But because it's negative, you put it's a strong negative correlation. So that's your first mark. Your second mark, well, not your second mark, sorry, to round off getting that, oh, is it worth two? Yeah, it's only worth 1 mark, sorry. So to round off getting that mark, you also need to apply it to the situation in question. Now, the particular situation is looking at the height of a town in metres, and obviously the corresponding temperature. Now, obviously, you can logically dictate the higher you're going to be, the windier it's going to be, obviously, the temperature is going to be lower. Okay, so really what you need to say is there's a strong negative correlation between the height of a town above sea level and the temperature. Okay, so in other words, therefore you'd put the higher the town is above the sea level, the lower the air temperature. Okay, so you need to relate it to the situation that you're being told about. Okay, so the next one, part D, is quite tricky actually. So what I'm going to do is obviously just write R over here somewhere and rub this out, because this next little bit is going to involve a little bit of working. Okay, even though it's only worth 3 marks, personally I think it should be worth a little bit more. Okay, so see, you've got R there. We're going to revisit that in a minute, that's why I haven't just rubbed it out. So this part D says that the student says, who's created this model, obviously a student, not, because they have the time to do these things. Okay, so they said it'd be easier if we said, well, we'll let H equal X over 1,000. Okay, because basically what that does is essentially coding the data. So each value for X is reduced by, it's divided by 1,000 even. Okay, so that just means all the numbers are reduced by the same proportion, essentially, so we don't lose any values, okay? Well, we do, obviously, but we'll come to what I mean by that in a minute. I'm trying not to give it away because it's one of the next questions. Right, so what it's asked to find us is the value of SHH. Now, the first thing I would do before bothering with any of trying to work out this is just write what SHH is. Now, obviously, if it was SXX, you would write, or SY, right, BE, so your sum, okay, of y squared, but because we're looking at H, it's the sum of H all squared, take the sum of H all squared, sorry, I do apologise about my E's, it's all squared over N. What we wanted to do is we wanted to sort of put this in now obviously we don't know the sum of H, we don't know the sum of H squared. All we know is, well, H is related to X, so what we've got to do is sort of, I'm trying to explain this in a way without giving it away, is we've got to put this in some kind of, we've got to be able to put this in some form of X, okay, some X value that we've worked out, either SXX or the sum of X or the sum of X all squared. We need to put that in this equation somehow, okay, because obviously we know H is equal to X over 1,000, so therefore it doesn't correspond to any value of Y. Okay, so we've got to put this in the form of SXX, because we don't have any other X values. We don't have the sum of X, and we don't have the sum of X squared. So obviously we've got to relate this to SXX. We've got to do SHH equals SXX times or divide or add something, okay? Now, quite clearly, that's not got any X values in. But the first thing we can do, well, the easiest thing to do is the sum of H, okay? Because obviously we don't know what the sum of H is. Now the sum of H, well, if we just put that in, okay, so the sum of H, that's just equal to the sum of X, because we're just doing the sum of everything, okay? Sum of X, and obviously the sum of 1,000 is just going to be 1,000, so we just write over 1,000. Okay, so that's the sum of H. That's what it's equal to in terms of X. Now we can apply this method to sum of H squared. Okay, well the sum of H is sum of X over 1,000, and what we need to do to get the sum of H from the H squared from the sum of H is square it. Okay, so to get the sum of H squared equation, we just square both sides of this. Okay, so therefore the sum of H squared is equal to sum of X. Sorry, I really do apologise. I'm just trying to do this quite smart, but obviously it's not working out for me. Okay, so the sum of x squared, sum of x over 1,000 all squared. In other words, it's the sum of x squared over 1,000 squared. You can write it either way, it doesn't really matter. Okay, so what we're going to do now is we'll sub each of these values. So we know what the sum of h squared is equal to, we know what the sum of h is equal to in terms of x. We're going to sub it in here and see where we can go from this, because quite clearly this is all we can do so far. So we just see where it takes us. Probably not the best way of explaining that, but it's the only way I can think of. Okay, so we know the sum of h squared, which is just the sum of x. I'll be so happy when I finish this sum question. Okay, the sum of x squared over 1,000 squared. Now you can obviously work out what 1,000 squared is, but I'm just keeping it as 1,000 squared and not giving you the raw figure, so you can see where we're transferring the numbers, obviously. Now the sum of h all squared. Well, we're just going to put what sum of h is and square it. There's no putting the sum of h squared, because the sum of h all squared is going to be different. Okay, so what we're going to do is just sub in the sum of h and square it. So the sum of h is the sum of x over 1,000. We're going to square top and bottom. And we're going to divide that by n, because we're applying it to this formula over here. Okay, so what we're going to do now is just simplify this a little bit. Okay, so the sum of SHH is equal to, well, the first bit doesn't change for the moment, I'm not simplifying that, so it's just sum of x squared over 1,000 squared. But this sum of x over 1,000 all squared, well, it's just going to be a sum of x squared over 1,000 squared over n. Okay, now, well, when we divide that by n, what we're going to get is the sum of x all squared, obviously. Sorry, sum of x squared over 1,000 squared n. Okay, so hopefully that makes some kind of sense. Oh, damn it! Sorry, put something wrong here. I think I made a slight error somewhere. I do apologise about this. There's no way to divide it in. I do apologise, one sec. No, that's fine. Sorry. Yeah, I've not made a mistake. I just thought I had. All right. So what can we do here to make this? We can put SXX in this somewhere. Well, let's just think about what SXX equals. Oh, SXX equals the sum of x squared. Take the sum of x all squared over n. And how do we put that in this formula? Well, both of them appear to be divided by 1,000, okay? 1,000 squared. So we've got the sum of x squared over 1,000 squared, and we've got the sum of x all squared over n divided by 1,000 squared. Now, what we can do is we take 1,000 squared out as a common factor. So SHH is equal to 1 over 1,000 squared, sorry. 1,000 squared. And when we do that, it looks like SXX, okay? So the sum of x squared takes sum of x all squared over n. And we know that is equal to SXX, okay? So we can sub SXX to be EX squared take EX all squared over n. So therefore SHH is equal to 1 over 1,000 squared times SXX. You can multiply this out, obviously. So therefore SHH is equal to, this SXX over 1,000 squared. Now, that obviously doesn't tell us what the value of SHH is, but we know the value of SXX, which is 3,535,237.5. So we sub that, we divide that by 1,000 squared, sub it in this equation, to get the value of SHH, which should get us 3.535, etc., and you would carry on. But that is the principle of what this question is asking. Right, now 1A, thankfully for me, it's not got any writing to do. Now it says write down the value of the correlation, Write down the value of the correlation between h and y. Well, obviously, we just rearrange x. Sorry, we rearrange x for h. Okay, so we'd sub this in into each one of these. But because we're changing each of the x values by the same amount, the proportion in terms of we're changing each value by the same amount. Okay, so the proportion to y hasn't changed. Therefore, well, essentially you can just learn the fact that coding does not affect the value of the PMCC. Plus the fact this is only worth 1 mark, so it's obviously not going to be requiring you. Well, the previous one was only worth 1 mark. That was only worth 1 freaking mark as well. So you can see what annoyance that is. Anyway, so that kind of goes out the window then. Well, it's only worth 1 mark, so it's obviously not going to ask you to get you to do that much work, even though this part D argues with that. So there is a quicker way of doing that. Anyway, the shorthand of it is that the coding does not affect the value of the PMCC, so therefore the PMCC is equal to what we got before of negative 0.871, not 1.871. That's all you really need to state for part 8. Okay, so that's question 1 out of the way. As I said, I think 1D was a real nasty one for only 1 mark. I think definitely the first question is 1A is worth 2, and that was only worth 1. And you had to do a lot more working for that. But I mean, that's the only method that I can see this working for. But if you have any other methods for 1D that work, please do let me know in the comments below. Or you know, if you want to message me through my obviously YouTube page, Facebook page, sorry, then you could do that as well, taking a photo of your answers, and I will re-upload another alternative video for this with your solutions, which I would be very grateful for, and I think everyone else out there would be, because that is quite a long method. But obviously don't skip, don't cut any corners, that's just obviously general stuff. But if you did the same way, then there's nothing wrong with that way, the way that I did 1D. But as I said, it's just a long way around, so some people might not have thought of that, because, you know, people are lazy the easier way, or like me, where I always do the long way, because, you know, why not? Okay, so thanks for watching. Hopefully it's been some help. As I said, sorry for being over there, but I just had to make sure I wasn't getting any answers wrong, because obviously, you know, I never do that, but just to be sure. Okay, so thanks for watching, and we'll see you in question 2.